Okay, so this is chapter 3, and this is going to be about adding and subtracting fractions. And so what I want to do is remind you of something I said a week or so ago, which seems critically important right now. If you need to add or subtract something, if you need to, you must have like things. So the assumption is if I'm adding 3 books and 2 pencils, I can't add them because they're not alike. And so this idea carries out all through this course into algebra, all the way around. It's a fundamental thing. It's so fundamental, I think people forget to mention it. But we must have like things. And so this is going to affect us with our fractions. But the other half of this rule that I always mention is you can multiply or divide anything by anything. Now this seems really strange. If you want to multiply or divide, go for it. It doesn't matter that they're alike or not. Nobody cares. But if you're going to add or subtract, we must have like things. And so this is going to affect us. Now, you may remember before we would multiply 2/3 times 3.5. There's nothing alike about this. And so we said, well, here's 2/3 and here is 6 and 1 is 7/2. And so this is in thirds and this is in halves, and we're going to multiply. And we could have divided just as easily if we wanted to. And so the only way to finish this problem is I happen to notice there's the 2's that needed to be reduced. And this is 7/3. 7 divided by 3, 1 times 7 is 7, 3 times 1 is 3. Or if you want to, 7 divided by 3 is 2 1/3. So when I multiplied, all I had to do was put it in proper fraction form and there was no restriction. But I'm saying all this because when I go to add 1/2 and 1/3, I can't do it yet. And the reason is because these are not like. And so what we're going to be working on is how to make them so that they're alike so that we can add them. And the answer will be to get a common denominator that will work for both of them. Now, I started with a fairly small example. The numbers were small, and from your past experience with this, you might know that the common denominator, anybody? 6. And the reason is both of these can be converted into 6. And so 2 can be converted into 6. And we did this a little bit before by multiplying by 3. And when you multiply this number by 3, you multiply this number by 3. So 2 times 3 is 6, and 1 times 3 is 3. So what we did here was 1/2 and 3/6 is the same thing. And this one can convert to 6 also very easily. But in this case, 3 to get to 6, you would multiply by 2. 3 times 2 is 6. 1 times 2 is 2. Now, although the first problem, 1/2 and 1/3, couldn't be added, this one can. Because they're alike now, they're like things. We have everything divided into portions of 6. So I showed you the pie. So a lot of times with a you know, a pie, you can divide it into 6 pieces. So this one's going to have 3 out of 6, 3/6. This one's got to have 2. And so now I can clearly add them. And so you add the numerators, 3 and 2 is 5, and it's in 6. And so hopefully, even without a lot of explanation, that sort of clicks. And so what did we need to add fractions? Common denominators, because we can't add them until we have it. And so this is the big job of adding and subtracting fractions. You have to have common denominators. Now, sometimes it's really easy to figure out. And so I'm going to start with this. Now, the trouble with what you've learned in the past and what you need right now is that sometimes you said, oh, well, I realized I could get a pretty good common denominator by multiplying 3 and 5 and getting 15. And the truth of the matter is 15 is the correct one for this. The problem is this won't always work. So what we're looking for is not the common denominator, but the least common denominator. Now, the reason I say least is we want the lowest. We don't want numbers like 150, which would have been a good denominator, but not the least. And so why do we want the least? Because as the numbers get larger and larger, the problem gets more and more tiresome and difficult. And so we want to work with the one that will be the lowest and still work for us. Does that make sense that 15 is the correct one? Because 3 can divide into 15 by multiplying by 5. And once you multiply the bottom by 5, you multiply the top by 5, which is equal to 1, and not really change it. 3 times 5 is 15. 1 times 5 is 5. Okay? I do the same with this. I know 5 will go into 15. And when I say go, I mean without fractions. In other words, it will multiply evenly. I want to multiply this one by 3 and this one by 3. This may not be the way you learned it, putting this number in, but this actually will be useful in algebra. And so I'm going to show it this way. 5 times 3 is 15. 1 times 3 is 3. The question is this now doable? Can we actually add it? And back to the original statement I said, if you want to add, you must have like things. And in terms of fractions, that would be a common denominator. Okay? Common denominator. I don't think I spelled that right. So let's go ahead and do it. I can add the 2 numerators. 5 and 3 is 8. And the common denominator was 15. So this is 8 over 15. Now there's no way to tell if this is reduced. And so you look at it to make sure it's reduced. 15, remember, is 3 by 5. And there's no 3 factors of 3 or 5 in the number 8. And so this is reduced. And so we could circle it and say, this answer is definitely good. Now, what they talk about in this first section is least common multiple. Least common multiple is the same thing as least common denominator. I'll spell it right this time. So they abbreviate these because of these long words. So this is LCM, least common multiple, and this is LCD, least common denominator. And the fact is, they're the same thing. And so I want to show you another problem. 3/4 plus 1/6. Now, in the very beginning of this chapter, all they do is they don't expect you to add it. They just expect you to find the lowest common denominator or the least common multiple. And so sometimes they would call this the lowest, but it's the same thing, least. And so is 4 something that will work for both of them? No. Is 6 something? Well, 6 would go into 6, but 4 won't go into 6. So the question is, what is the correct number? And so I'm going to use this example, and you may have already figured out the correct answer, but I want to show you the process. To do multiples of 4, 4 times 4 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and it would keep on going, wouldn't it? So those are multiples of 4. Now I'm going to do multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And here's 24. I went further than I needed to. These are all multiples. Multiples of 5, 5, 10, 15, 20. These are multiples. The least common multiple is the first time there's a match. There's no matches with the 4 and the 6, the 8, but wait a minute. The first time there's a match with multiples is the number 12. Can you see it? There may be some other ones further down the road, but this is the lowest. And so this is the one we would use. And so if they say, what's the least common multiple? The answer would be 12. Now, knowing how people want shortcuts, and these problems are not so big that you can't make a decent guess already anyway. Here's a shortcut. If you take the larger one, which is the 6, and just do multiples, 6 is not big enough. And if it was, I'd use it, but it's not. But the very next multiple is 12, and 4 goes into 12. 12 is it. And so I'm going to use that concept, going with the larger one of the two. So let me show you what I mean. If I had 1/4 plus 1/8, and somebody said, all I want is the least common multiple, or they could ask for the least common denominator, which is the same thing. The first thing you would do is look at the two numbers and notice they don't match. And so, okay, fine. So they don't match. My next thing would be, I would go to the larger one. Is that a number that could be used for a common denominator? Is 8 sufficient? Would 8 work? Yes, it would. Well, this one will just copy. And this one, 4, can go into 8 just by multiplying by 2. So the least common multiple, lowest common denominator, would be 8. So the first thing you do when they don't match is to see if the bigger one will work. And if it will work, then you will use it. And if it won't work, okay, let's find another problem. Let's see. In this particular problem, they don't match. Therefore, we have to find a way to get them to have a common denominator. Can 15 work? Because if it can work, that would be the lowest one we would use. And so it's really a matter of, can you convert them both into 15s? Something over 15. This one would go 1 over 15. This one, 3 divides nicely. And so if I brought in a 5, 3 times 5 is 15. 1 times 5 is 5. So 15 would be sufficient. So let me try to find a different one.
Question on
Go
that
ahead.
one. Go back. Can you go back to that one for a sec?
Yeah.
Okay, so you don't break it down anymore.
No. And the
Okay,
reason
just,
is, well, our goal was to
okay,
have those to match.
okay,
And
gotcha.
so you don't want to undo your good work.
okay.
Good job. That's a good question. Okay. Now, will 9 work for both of them? Can I turn 4 into a 9 using whole numbers? I don't think so. Do you?
No.
No. Does anybody know what the common denominator is?
36?
Yeah.
36.
36. So when sometimes you multiply the two denominators and it worked, this is an example of when it worked. But what I want to do, the real answer comes in the fact that there's no common factors in the 4 and the 9. In other words, this all boils down to prime numbers. And I don't know if you remember from before, but prime numbers, let me review it. Prime numbers. So there's actually 2 ways to see a prime number. One way is through multiplication. So 5 is a prime number because the only way to multiply it is 1 times 5. There's no other ways to do it. Another way to look at prime numbers is the only number that divides into 5 would be 5 or 1. You can't divide 5 except by 5 or 1, or you can think of it through multiplication. The only way to get it is to multiply it itself by 1. So the prime numbers, here they are. This is the key to all of this. Now 9 is not a prime because it's 3 times 3. So there's other ways to get it. The word was composite, who cares? But 9 is not good, but 11 is. Because 11 times 1, that's the only way. 13 times 1, that's the only way. 15 is no good because it has other factors. 15 is really 3 by 5, so forget it. How about 17? Good. And 19, and I'm going to stop there because I think that's more than what we need.
Other question.
Yeah.
So if you go back to the one that you just did.
Yeah.
Question. Okay.
That's where I was going. That's exactly where I was going.
Oh, so 9 times 4 is 36. Do you always take those two numbers and multiply them?
No.
If there's no.
Okay, you're getting there. You're getting there. 4, this is, you're putting it together. 4 is actually made up of 2 times 2.
Right.
All right. And 9 is actually made up of 3 times 3. And do they have anything in common? Do they both have a pair of 2s or some 2s or 3s? They don't. They have nothing in common. Therefore, the lowest common denominator will be the product of these two. You've got to cover a pair of 2s and a pair of 3s, and there's nothing in common. So you're stuck with 36. So that's the case where you go to the like that. I had another example. Let me see. Whoops. Let me go back. This one. When I had 1/3 and 1/5, these were both prime numbers. And so there's nothing common. And therefore, the common denominator ends up being 3 times 5. On the other hand, this one, I'm going to use this. 4 is made up of 2 times 2. And 6 is made up of 2 times 3. Okay? So we don't multiply 4 times 6 to get 24 because we actually have a common 2. And so the rule they use, and it's, sometimes it's hard to explain it, but the rule they use about if you know the primes, you take the most 2's, so the least common denominator. One of them has a pair of 2's, so I would take the most 2's. I don't have to take this one because it's already covered by these. And the most 3's. So I had, for 2's, I had 2 of them. So I wrote that down. For 3's, I only had 1 of them. This is 2 times 2 is 4 times 3 is 12. This is the lowest common denominator no matter what. Now they're showing this method, and we're going to have to do it several times, but they're showing this method of looking at the primes so that when the problem gets hard, you will have a way to get it perfect. Okay? And so the primes are the key. So it is 12, and we figured it out with multiples that it was 12. But the reason we didn't use 24 was because there was a 2 in here and a 2 in here. So we didn't have to use every bit of this 4 times 6. We were able to get it at a lower amount. And so we do want the lowest or the least. And so it ended up being 12. Okay, anybody want to ask a question about that? At least the general concept.
As we go forward, we'll say we end up with, I don't know, what is it? Like the next one would be 3/12. We will simplify it, right? Like, or is that just going to be?
Yes. In other words, when we go ahead and add them, without saying, the rule is that every answer should be as simple as possible. And so if this would reduce it. So there's no guarantee that when you go ahead and add them like you should, that's the reduced answer. So you have to reduce it. So if somehow you get 10 over 20 for a final answer, you would say, my answer is 1/2. Right.
Thank you.
So that's if the 15 was a 16.
Yes,
Eight goes
exactly.
into
Now
eight.
we're thinking. So
Okay,
if that had been the final answer, you'd say, oh, we like them reduced. And so you'd say, oh, I see a factor of 8 in here. 8 goes into 8 once, 8 goes into 16 twice,
Okay.
and you would have turned it into that.
okay.
So you do have that. So let me see. They kind of hinted at this before. Find the least common denominator of these fractions. And when they ask you to do that, least common denominator is the same as lowest common multiple. You're only going to give them one number. What would be the denominator if you actually did add them? We're not going to.
Oh,
Can you tell what it's going to be? Even the way it's written?
16.
It is 16. So your first, when you realize you don't have common denominators, if you had common denominators, you say, thank you very much. I'm going to finish this problem and I'll be done with it. But if you don't have common denominators, then the first thing you look at all the numbers, but you, especially the biggest, because if the biggest will work, you're done. Well, I mean, you're done with the hard part as far as I'm concerned, because 8 would divide into 16, 4 would divide into 16, 2 into 16, everybody would divide into 16. All you have to do is give them the number 16. Okay.
Professor,
Yes.
what do you, I got stuck on a question from the homework that was on that same topic. The
Okay,
numbers
let's
that
see what
were,
it looks like.
all right, the numbers that were given were, it said, find the least common denominator for 1/3,
Yep.
1/4,
Okay.
1/5,
Oh, gosh.
and 1/8.
Okay. All right. It's as if we would, so that's quite a bit. Let me take this one out for the moment and see if we can't do this much, and then I'll bring in the 8. The simplest way to do this probably is with primes. The prime 3 is already prime, okay? 4, we just did it a minute ago, is actually 2 times 2, right?
Yep.
And 5 is also prime. So when you do the least common denominator, which is also the least common multiple, you look at your numbers, your 2s and your 3s and your 5s, and you take the most in any one. So the most 2s I see are from this one, and it would be 2 of them. The most 3s I see in any particular number is just 1. And the most 5s I see are just 1. So the truth is, when I did just these first 3, I had to take the whole thing. And so I'm going to go ahead and do this. I'm going to multiply this out. 2 times 2 is 4,
4.
times 3 is 12, and 12 times 5, 0, carry a 1, is 60. Now, being a lazy person, can you accept it? I know what I can get away with. You know what I'm saying? I know what I'm allowed to do. And so I'm going to get a little piece of paper and show you why. You see those 4 numbers? 2, 2, 3, 5?
Yeah.
You know what I just did? I used the commutative and the associative property to make my life easier. You see what I did, why I did this? 2 times 5 is 10. 2 times 3 is 6. I got my answer. I didn't have to sweat it.
Right.
So knowing that rule is a good thing. Could you do it the way we did it? Of course you could. Did you see my point?
Yes.
Occasionally you see a good break and you use it. That doesn't mean you see it every time.
So you don't use the 1/8 at all?
I'm going to do that now.
Oh,
Okay, so what I wanted to do is take it without so much. So let's do the 1/8. So I need more paper. Okay. So if I brought in the 1/8, the prime factors of 3 were 3. The prime factors of 4 were 2 by 2. The prime factors of 5 were 5. And now I've got to do 8. 8, some people like the tree. I like the division, but 2 goes into 8 4 times, and 2 goes into 4 twice. So 8 is really 2, 2, 2. 2 times 2 is 4, times 2 is 8. That's 8. A 2, a 2, and a 2. Okay?
Okay.
So if I had to do the least common multiple, which is also the lowest common denominator, or whatever you want to call it. I would look at these four numbers, and I like to stack them so I can see them like that. Which number has the most twos?
8.
This one. And so this is the one I'm going to take. 2, 2, and 2. Which number has the most threes? This one, right? It's the only one that has threes. So the
Yeah.
most I have would be a single. And which one has the most fives? It would be this
That
one,
one, the 5.
and I would take the 5. So I didn't need to take all of these twos. There's 5 of them, 3 here and 2 there. I just had to take the one that had the most. And so this is my common denominator. Now, so I could, play games, or I could do it, left to right. 2 times 2 is 4, times 2 is 8. 8 times 3 is 24. 24 times 5, this is 20, carry a 2. This is 120, and that is the lowest. That's why I did it in 2 steps, because I knew the answer was going to be quite big. But this is these primes, this is the technique that will be perfect, that will work for you every time and give you the lowest guaranteed. Do you use it every time? No. Half the time you can see it without all this fuss. But when it gets tough, we only needed 3 twos, the one that had the most. And that was it. And then a 3 to cover that, and a 5 to cover that. And then I multiplied it, although I could have played my game. 2 times 5 is 10, and then this would be 2 times 2 is 4, times 3 is 12, 10 times 12 is 120. I could have played that game if I wanted to. That's a good one. You may
Thank
not
you.
be ready for that, but that was, I'm sure there's some others that are not quite as bad. Did anybody else try some problems?
Thank you so much, Professor.
Okay, that's the trick. Sometimes here's what I saw. They just want the least common multiple. Now we could do it with primes, or we could do it with multiples. And the way I would do it, if I did it with multiples, is I would do the multiples of 40, because you get there faster by using the larger number. And so the multiples of 40, 40 times 1 is 40, 40 times 2 is 80, 40 times 3, right?
60.
Will 30 go into 120?
Yes.
Sold. That is your least common multiple. And I don't have to do the 30s, although I could, but I think you can see that 30 goes into 120 and 4 times, and so I could use 120. Let me find a different one. Okay. All they want is the lowest common denominator. They don't expect you to finish it. Now, we could do it with multiples, or we could do it with primes. And I think it's going to be a toss-up, which is the best. I'm going to show the primes. I think I'm going to show the primes. This is 16, which is made up of a whole string of 2s. So 2 goes into 16 8 times. 2 goes into 8 4 times, and 2 goes into 4 twice. So 16 is really 2, 2, 2, and 2. 12, on the other hand, 2 into 12 goes 6. 2 into 6 is 3. And when you hit the prime, you're done. So that's 12, 2, 2, and 3. Okay, this is one approach. The least common multiple, lowest common denominator. You see 2s and you see, well, one little 3. So you take the most 2s in any of the numbers, any of the rows, and the most would be this top one, 4 of them. 1, 2, 3, 4. And the most 3s would be what?
Just 1 3.
Just one. So if you remember that string of 2s, we already did it. It's right here in our face. 2, 2, 2, 2. 4 2s is actually 16. I don't need to redo that. It's it right there. And then 16 times 3 happens to be 48. 48 is the lowest common denominator for these two numbers. So you would turn them both into 48. They would both go into 48 perfectly. I don't know if this, if you want to do this as factor trees, that's fine. I think I've found better luck with this myself, just dividing it down, starting with the lowest prime and working my way through until I hit a prime at the bottom. Now, I'm going to take those same two numbers, 9 over 16 and 7 over 12, and I'm going to do it with multiples. So we want the lowest common denominator or the least common multiple. I'm going to do multiples of 16. This is another approach that should work. 16 times 1 is 16. Of course, 16 is not going to work for 12. 12 can't go into 16. 16 times 2 is actually 32. You can do it on the side if you need to, but 12 doesn't go into 32. You could try it, but it doesn't go. It doesn't go in evenly. 16 times 3, this is 18 and is 48. Ah, 48. 16 times 3 is 48. Does 12 take you into 48?
Yes.
It does. So the least common denominator or least common multiple is 48. So it all depends on your comfort level of doing multiples, because if you make a mistake on the multiples, you might not see the right answer, but it is 48, isn't it? How about 12 and 8? No, let's try. Least common multiple of these three numbers. So these are all denominators, but I just need, I'm not even going to make the fraction. Okay, so now what? How are you going to do it? Did you like multiples?
Multiplying? No.
8 and 4.
Yeah, 8 and 4. 8 would work for 4, but it won't work for 5. Because if you need to see how this would work, you could say, well, could I turn them all into 8s? And I could turn the 8 into 8s and the 4 into 8, but I can't take the 5 into 8s. So I've got to consider what might work. So I turned this into a problem so you can see where it's headed. But if you did multiples, 8 times 1 is 8. 8 times 2 is 16. But I can't do 5 into 16, can I? 8 times 3 is 24. I can't do 5 into 24. 8 times 4 is what? 32. 5 still won't divide into that. 8 times 5 is 40. 8 goes into 40, 5 goes into 40, 4 goes into 40. This turned out to be the lowest common multiple. But let's try it with primes. The numbers were 8 and 5 and 4. I'm looking for the least common multiple or lowest common denominator. 8, I don't know if you remember it, but after a while you get pretty good at remembering this. 8 was really 3 2s. 5 was just 5. And 4 was what?
2 times 2.
2 times 2. I stack them so I can see which one has the most. And all I'm seeing are 2s and 5s. So the most 2s would be this one. This has more than that. So I take the most, that's all I need is the one that has the most. And then as far as 5 goes, I just need 1. This might have been quicker. This is 8 times 5 is 40. That is your least common multiple. Okay. Now, what they do with this, of course, is to actually do some adding. And so I'm going to slip us over to 3.2. And so I'll tell you this right now. Because of space considerations, the book writes a problem like this. But what I've found is most students have better luck with the problem written vertically. In case I have to change it to common denominators. This one you didn't, but I'm going to write all my problems vertically like this in case I have to expand it. And so there's nothing wrong with that approach this way, but I think this works out better for most students. So the first thing you do with this problem is you look at the denominators. They're the same. What do you say? Thank goodness. I don't have to fool with this. So the common denominator will be 6, and all I need to do is add the numerator. So 3 and 1 is 4. And so the question is that the answer I turn in? 4 divided by 6. I said it earlier. Is that going to get you credit?
No.
No. This happens to reduce. And so we're going to simplify it by dividing by 2. 2 into 4 is 2. 2 into 6 is 3. This is the answer I would turn in. Okay? So it doesn't matter if it's subtract. I'm giving you the easy ones. Common denominator, life is good. It's going to be fourths. 3 take away 1 is 2. 2 fourths. But guess what? The same exact problem as before. 2 fourths, divide by 2. 2 into 2, 1. 2 into 4, twice. There's your answer. And so whether it's add or subtract shouldn't matter. But now, let's see about this one. Okay? The denominators don't match. We can't add them unless they match. In other words, we can't add things that are unlike. And so we have to add like things. And so the first thing I would do, and this is going to work out very nicely, is to look at the larger of the two denominators and ask yourself, is that good enough to be the common denominator? And the answer is yes, that is definitely good enough because both of them will work with 9. So this particular thing, I just need to copy it because it's already in ninths. And this one here, I need to convert it to ninths. And so it's multiplied by 3, and I'm going to have 3 over 3. 1 times 3 is 3. Now I have common denominators. So I'm adding like things. And so I add the numerator, which is 7, and copy the denominator. I double check this to make sure it's reduced. And if it's reduced, I grab it. And I think circling is a good idea. And then that's it. So if the denominator works, let me see if I can find, let's see, it's our next level up. Here's a subtract. Don't be concerned about subtract. It's just there. Okay. So because this is prime and this is prime, what's the common denominator?
10.
It's 10. Because the most 2's would be one of them, the most 5's would be one of them. 2 times 5 is 10. This is the case where you ended up multiplying the two denominators because there was nothing in common. And so in this particular case, to get 2 into 10, I'm going to go 5 over 5 like that. So you do the denominator first. 2 times 5 is 10. 1 times 5 is 5. Notice I'm putting a dot here to remind me that it's multiply. This one here, this is a 5, wants to be a 10.
2.
It's a wannabe. It needs a 2 over 2. 5 times 2 is 10. 1 times 2 is 2. And this is definitely subtract. Don't forget that. So 5 take away 2 is 3. The common denominator is 10. That's the only difference between add and subtract. And so you just have to subtract at the end instead of add. And so you check this out. Do you think that's as reduced as good as it's going to get?
Yes.
I think so too. Let's have it. How is that? Let's see. Okay, let me do one that's a little bit harder. This is 3/4 plus 1/8 plus 5 over 6. When you have 3 numbers, 3 fractions, you've got to find a common denominator that's good for all 3 at the same time. Now, if it had just been the 3 and this one, the 4 and the 8, we would have used 8. But now I've got a 6 in here, and so I've got to figure out what it could be. I'm going to move it to a separate sheet of paper. The 4, the 8, and the 6. I'm going to try to figure that out. The 4, the 8, and the 6. I'm actually trying to find the lowest common multiple, lowest common denominator, whatever.
8.
It's got to be as large as the largest one. That's the rule. So it has to be at least 8. But
Yeah.
see, 6 won't go into 8.
The
Right?
24.
But
It
2
is
will.
24.
But
So here's 2 ways to do it. When the numbers are not too hard, too big, you might get away with multiples. So 8 times 1 is 8. 8 times 2 is 16. but 6 doesn't go into 16. But 8 times 3 is 24. That's one approach, the multiples. How do you like it? Do you like it? So start with the biggest one, because the denominator has to be as big as the biggest one or bigger. And so I have to work with the 8. 8 times 2 is 16. 16 wouldn't have worked, but 24 would. And we could do it with multiples, or we can do it with primes, but let's do it. We decided it was 24. If you get what else would have worked? Well, 48 would have worked and 120 would have worked, but we don't want that big number. We want the smallest one so that we can keep track of things. So the 4 wants to be 24. So we need to bring in a factor of 6, and so that's 6 over 6. 4 times 6 is 24. 3 times 6 is 18. The 8 wants to be 24. It needs a factor of 3. And so all your multiplication tables are going to really matter here. 8 times 3 is 24. 1 times 3 is 3. And finally, 6 wants to be a 24. It needs a factor of 4, and we do it fairly. 4 over 4. 6 times 4 is 24. 5 times 4 is 20. Why is this problem over here 10 times better than the original problem? Because we now have like things. So it's fair to add them. And so everything's going to be in 24ths. And so what I have to do is add, 18 and 3 and 20. This is 8 and 3 is 11, carry a 1. 2, 3, 4. I'm getting 41. If I'm getting something wrong, just tell me, but I think that's it. So this, we need to decide, do you think there's a number that reduces this? We could make it a mixed number. That's definitely something we could do. And so it depends on the instructions. I pulled it out of somewhere and I don't know what the instructions were. But 41, I believe, is a prime number. And 24 is 2s and 3s. I don't think this reduces further. But if you wanted to, you could make this a mixed number. So 24 into 41 goes once. This is 17. So that would be 1. How much is left over? 17 over the common 24. So that's one answer. That's another. Okay,
I have a question.
certainly.
I'm getting confused now. I am. Okay, so why can't you use, I know this sounds, the 8
The
and
8.
2? Okay, like 2 goes into all of them.
Well, no, we're not taking the numbers lower, we're taking the numbers higher. And so if we had picked, let's go back to this. Let's go back to the original problem. If we had picked 2, I can't turn these into 2s. It wouldn't.
Oh,
If I
because
divide 4 divided by 2 is 2. 3 divided by 2 is a fraction.
okay.
We've just made it worse. So it
Okay.
has to go up. And so the only possible good scenario is the largest one is sufficient for all 3. But that wasn't the case here. It wasn't good enough. The lowest one actually was 24. So the thing to remember is that this number 24, the lowest common denominator, has to be at least as big as the biggest, probably bigger, so that they can all match 24ths, 24, 24. So they can all match so that we're adding like things. Everything's in 24ths. Mhm. Let me
Okay.
see. Anybody else find a, let me see. Oh, I found one. 12 over 28. And 9 over 20.
I have a question,
Yes.
but it's related. It's not related to a problem. It's related to the test that we took on Monday.
Okay.
It still shows on XYZ that I can use a late pass for my test, like I haven't submitted it.
That was a mistake. The late, I realized it in the, once we started the exam that I hadn't undone that switch. But late passes, I'll have to talk to you after class, but late passes were not, everybody was to do it on Monday from 9 to 10.
I know, I think I did that, but it's still confusing me because it's saying use your late pass, like as if I did it.
No. That was a mistake, and I couldn't undo it in the middle of the test without
Okay.
throwing everything off. So
Okay.
that was a mistake. I wanted to show this particular problem because once in a while it looks like, oh, I've got to figure out 28 and 20, right? But this is something I want you to think about before you get carried away. The 12 over 28 could be reduced. And if it can be reduced, why don't we do the smaller problem instead of the larger problem? Do you see what I'm saying? What would we divide this by? 12 over 28. I want to reduce it so that I don't have to try to figure out 28 and 20. What number would divide 12 and 28?
Four.
Yeah, clearly 2 would have worked, but 4 is even better. If I divide 4 into 12, I've got 3, and 4 into 28 is 7. I'd much rather do this problem. And so now the problem turns out into, instead of 12 over 28, I've got 3 over 7. I like that 10 times better. And it may be easier to figure out a common denominator. I noticed in a class of say 30 people, a regular class way back in junior high, when they'd say, can anybody figure out the common denominator? And one person would figure it out. And life didn't seem fair. Why did that one person see it? I think they were seeing primes. Can anybody, we want to guess this, or do we, or can you see what it's going to be?
I think, can I guess it?
Go ahead and guess it.
Just thought, 7? No, 9.
140.
Ah, now we're hitting it.
How?
It is 140. And so it ended up being the product of these two. And the reason is this was prime 7, right? And so you had to include, that had to be included in this denominator. And 20, I don't know if you remember it from before, is made up of a 2, another 2, and a 5. And so all of this had to be included. All of this had to be included. That's why you ended up multiplying 7 times 20. It had to be 140. Let's see if we can actually finish this problem. 7 divides into 140. How many times? 7 into 14 is?
20.
It
I mean,
goes 20 times. Yeah, you're right. And then you can check to see that you pick the right number, because 7 times 20 is 140. That's correct. 3 times 20 is 60. And we had to raise it to higher terms so that we'd have a match. Now I need to do this one. This is 20 times something is 140. Well, if you look up here, you could see what it needs to be. 20 times
7.
7. So 20 times 7 is 140. 9 times 7 is
63.
3. So 60 and 63 happens to be 123 over 140. Now the question is, could this reduce? We haven't had one that was this high to try to reduce it. But if you're going to try, the primes always end up being your best shot. Does 2 divide into both of those numbers? Can I divide this by 2 and this by 2 at the same time? Nope, because this one is odd. Can I divide 3 into both numbers? I can divide 3 into this because it adds to 1 and 2 is 3 and 3 is 6. I can divide 3 into this, but I can't divide 3 into that. You could do it out if you want to see it's no good. Can I divide 5 into both numbers? 5 will go into 140, but it won't go into this. What's the next prime? The next prime is 7. I don't think this is going to do. Do you? 7 goes into 140, but I don't think it's going to go into this if you divide it out. I think this is done. And I don't want to labor that to go at this too much, but that's, I think that's our final answer. The reason I showed this problem was because it was too big to begin with. This particular number could be reduced, even though it was still a project, to 3 over 7. And that made the problem easier to do. Now, let's go. How's our time? Oh, it's after 10. Good grief. Okay. So I don't know if there's enough there, but I'm going to stop recording.